In this video, we're going to be looking at the naming and drawing of alkanes. What you're seeing in this picture is the burning of natural gas, and natural gas is predominantly methane with some ethane in it. Okay, a functional group. Alkanes are hydrocarbons, and hydrocarbons consist of carbon and hydrogen. And they only contain single bonds. So in this picture here, you're seeing methane. So this would represent the carbon atom, and it's bonded to 4 hydrogen atoms. The arrangement is tetrahedral, and this is to spread the electron pairs as far apart as possible. The molecules, which is what they are said to be saturated, and that's because they only contain carbon-carbon single bonds. So now let's look at how to name alkanes. So the stem or parent name tells us the prefix. So if you've got 1 carbon, it's meth, 2 eth, 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. So to name the hydrocarbons, the first thing you need to do is find the longest chain. So you count and you go 1, 2, 3, 4, 5, 6, or you go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So 6 is the longest chain. So it's got 6 carbons. So this is the parent name. So hex for 6, ane because it's single bonded, and that's your parent name. Now, you now must decide on the best way of numbering. So you start at either end. So you would count 1 from either end and 2. So you go 1, 1, 2, 2, and you find the first point of difference. And the first point of difference starts from going left to right. So then this becomes 1, 2, 3, 4, 5, 6. And these numbers provide an address for the additional components on the main chain. Now the next part of the chain is the substituent or alkyl part. Now these are the branches. So we can see one branch here, and we can see a bromo. So these are the bits that are added on. Now because there is 1 carbon in this branch, it is a meth. So the substituent or alkyl group is methyl. Now we must provide it with an address, and you can see it's attached to carbon number 2, so it's 2-methyl. Now then we have a bromo group. So this is a functional group in prefix. So it becomes a bromo. So this is functional group in prefix. Now we must provide an address. It's 3-bromo. Now between numbers and numbers, we have commas, and numbers and words, we have a dash. So dash. So this becomes 3-bromo, 2-methyl hexane. Now I would like you to try naming this alkane. So you need to stop the video and have a go. So this is the naming. So we start from either end and find the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 is the longest. Then you need to find which way to number it. So the parent name is pent, and as it's all single bonded, it's pentane. Now you need to find the first point of difference. So you start numbering from either end, and you go 1, 2, and the first point of difference is here. So this is the end we're going to name from. So this becomes 3, 4, and 5. And I'm circling my branches. Now, in this branch, there is 1 carbon. So this is a methyl. In this branch here, there is also 1 carbon. So it is a methyl as well. So we've got 2 methyls. So we go methyl. And because we've got 2 of them, it's a dimethyl. Now, we need to provide the address, which is 2, 3 dimethyl pentane. Now try naming this one. Remember to stop the video and then have a go. So once again, you need to find the longest chain. So numbering 1, 2, 3, 4, 1, 2, 3, 4, or 1, 2, 3, 4, 5. So that's the longest chain. Now you start from either end. So this is your long chain. If you start 1, 2, 3, then this will be on carbon number 3. And if you start this way, 1, 2, 3, it's on carbon number 3. So it doesn't matter. So 1, 2, 3, 4, 5. So it is a pent, is the parent name, and it's pentane because it's single bonded. Now we have on carbon number 3, there is 1 carbon. So this is a methyl group. So we go, it's methyl. And we need to provide an address, so it's 3-methyl pentane. Now try naming this one. Remember to stop the video and have a go. So looking for the longest chain, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. So 5 is the longest, so that pentane, because it's all single bond. Now you need the first point of difference, and it has to be this thing, which is a bromo. So 1, 2, 3, 4, 5. And that puts the bromo in the lowest position. Now, the substituent or alkyl group is a 1 carbon, so this is a methyl. So it becomes methyl pentane, and it's on carbon number 3. And then we've got 2 bromos, so bromo dash, so it's dibromo, and it is on carbon 1 and carbon 4. Now we're going to have a go at drawing the alkanes, which is actually a little bit easier. When drawing an alkane, we always start with the parent chain. So in this case, it's a hexane. So we draw 1, 2, 3, 4, 5, and 6. I'm going to number them. We then need to draw the branches, and on carbon 4 we have a methyl, so that's 1 carbon. And on carbon number 3 we have an ethyl group, which is 2 carbons. Then I'm going to put on my functional groups in prefix, which is on carbon number 3 I have a chloro, and on carbon number 1 I have a bromo, and on carbon number 5 I have a bromo. I now need to complete and satisfy my bonding by putting in hydrogens. So remember, each carbon must have 4 bonds. I've managed to draw a hydrocarbon. I would now like you to try and draw some of these alkanes. So make sure you stop the video and have a go. So when you're drawing, you always start with the parent name. Butane is 4 carbons, so I put my 4 carbons in. And then I draw my 2 branches, which is a dimethyl, so there's a branch on carbon number 2 and a branch on carbon number 3. And then I have to satisfy my bonding by putting in my hydrogen at try the next one. Pent means 5. I'm going to put on carbon number 3 and 4 a branch, which is a carbon, 1 methyl, so 1 carbon on each one. And on carbon number 1, I'm going to put on a chlorine, chlorine, and a chlorine. Now I must satisfy the bonding for carbon by putting on, making sure that each carbon has 4 bonds. Remember, it doesn't matter if you draw up or down because these will rotate, these single bonds. Last one, dimethylpropane. Now it hasn't told you where the 2 methyls go. That means they can only possibly go in one position. And they have to be on the middle carbon here, otherwise it would change the length of the main chain. Remember to satisfy your bonding by putting in the hydrogens for each carbon so they have 4 bonds. I'd like you to try some yourself. Go to the OneNote, Organic, Hydrocarbons, Naming and Drawing Alkanes.